Hi everyone and welcome to this new video of Data Science at Scale with VerticaPy. It's Badr speaking. Today, football fans will be happy. We will show how to rank UEFA Euro 2021 teams using VerticaPy. The complexity of the use case resides on setting clearly the problem. How is it possible to do predictions using the available information? Should we compute players' KPIs or is it enough to use team scores? UEFA European Championship evolved during time by including more and more teams. First edition took place in 1958, and it is organized each 4 years, except for the current edition which was delayed because of COVID-19. Spain and Germany are the two most successful teams with 3 titles. And in the last championship, France faced Portugal in final. France got its best team since 1998 and they were at home. They lost 1-0. We can see the complexity of the use case where predicting the exact rank might be hard and it is totally different than predicting the game's outcome. Indeed, predicting ranks is to affect a unique integer to each championship team and looking at their final position. Whereas predicting game's outcomes is a different problem where for each game, we will try to predict which team will win. Ranking teams is really team-oriented. It is a regression problem, where the entire team past performance must be considered and it is less subject to local effects where each player can make the difference. Ongoing assessment will make the difference as most of the time good teams will have very good ranks. Whereas when predicting games outcomes, the game strategy and the players are important factors. Depending on how we set up the problematic, it can be either a classification problem, predicting the game's winner, or a regression, predicting the team scores. The team performance is important, but we are in a very specific configuration where knowing the game's key features is really important. When doing football predictions, we are dealing with a time series use case. Indeed, each team got different KPIs for the different competitions, like the Euro or the World Cup. We need to predict the future using information we have for the past games. Some variables might give advantages to the concerned teams. Being at home might increase the global team confidence, having a good dynamic as well. And of course some other KPIs like the number of goals conceded in the last competition, or the number of goals scored, or the number of games played, can be very important. We cannot find the exact causality of each competition as too many factors may lead a team to the top. But there are strong correlations between teams' near past performances and future performance. There are multiple challenges when we try to compute the different KPIs. Teams can be away or at home, and they can be placed in 2 different columns. For example, in the first column we might miss some France's games because they are at the right side. It is then very hard to group the different elements. We will need to transpose some games or even to duplicate them. We will be then able to aggregate and to compute the different KPIs. Like if the team is playing at home, if the team won the competition, etc. Another challenge is to compute the different team competition ranks. Fortunately, there is a possible solution. We have to order the different competition games using the date descending. We can then create an identifier. This identifier will be transformed knowing that the last game corresponds to the final. The 2 games right after corresponds to the semi-final. Then we have the quarters finals until we reach the first round. We can compute KPIs for each round and create a new identifier by sorting by the round's IDs and KPIs. We have then the final identifier, which is representing the team's rankings. When our variables are created, we need to use autoregressive part of some variables and other exogenous variables that we know in advance. For example, we know which team will organize the next competition. We can use machine learning to build a regression model and predict the team's future ranks. However, you might ask yourself, how a regression model will predict exact integers? It will not. It will return floats. that we will order and affect to a unique identifier that will represent our predictions. Wow, we saw a lot of concepts. It is time to put them into action. It's important to do some hands-on. We will use VerticaPy and Jupyter to do football ranking predictions. We will ingest the dataset, do the game's transpositions, prepare the dataset, do some features engineering by building teams' KPIs, train a linear regression model, do the rankings prediction. Let's go! Let's use Jupyter Notebook to illustrate this topic. Let's load the VerticaPy package and its SQL extension. In VerticaPy, it is possible to work in both SQL and Python. Everything will happen inside the database. Be sure to have the same or an upper version to avoid compatibility issues. Let's create a new schema for the study. We will name it football. Let's load the football dataset in the Vertica database. We use the readCSV function with the parameter parseInLines to only parse few lines for type identifications. After guessing the different data types, it will ingest the entire dataset. We can see that we have the date and scores of the different football games since the beginning of football. We can duplicate and transpose the dataset in order to get all the teams in the two sides of the table. We can add an identifier to be able to track the duplicated games. We can create some easy features like if the team is at home, the game winner, the year. We can filter and keep only important competitions like World Cup or Euro. To be able to aggregate, we need a competition identifier. We know that the competition happens through multiple rounds during 2 consecutive years with 1 year of break. We can use sessionization to create this feature. As the first World Cup edition did not have qualifications round, we need to increment it. It's possible to compute the rank by first mapping the different rounds to a number, and then creating an incremental variable ordered by the team's KPIs. We can then aggregate and get the final team KPIs, which will be used to build our time series model. We can smooth the ranks and create the 2021 editions with empty values. Let's look at the rank for the last World Cup. We can notice that the ranks created are matching with the real ones. France in first position, and then we have Croatia, Belgium, England, etc. Many advanced analytical features can be created. We will use the autoregressive part of our variables to build predictors. We will also use movingwindows to look at the 3 past competitions. When everything is ready, we have our final dataset and it is time to switch to machine learning. It is clear that we can transform our dataset using PCA to verify Gauss-Markov assumptions, but we will use the feature importance part, which is in this case very important. We can fit our model with our predictors and we can compute different metrics and the feature's importance. The model is not bad at all with an adjusted R-squared of 0.67. It has some insignificant features, but it seems that playing a lot of World Cup games can be decisive to get a good rank. We can also notice that being at home gives a huge advantage. The last ranks are also influencing the model decision. We need now to smooth the ranks and do the predictions for the 2021 Championship edition. It seems that Germany, Spain, France and Portugal are favorites. In the last position we got North Macedonia, which is a total outsider. Let's examine why Germany is in the first position. We can use SHAP integration and create a SHAP explainer of our model to explain the record. It seems that in the last 3 World Cup they did great. They did not perform so well in the last Euros, and that's why those variables are making the rank worst. But at the end they seem to have huge chances to go far into the competition. If we do the same with North Macedonia, we can understand that the model does not expect them to go far because they have never done high-level competitions. Their previous ranks are not very good. We can see the power of VerticaPy for making easy some very complex problems. We can use in-database machine learning advanced analytical features like moving windows and sessionization to create amazing features. It is just magic. Thank you for watching this video. If you liked it, subscribe to the VerticaPy channel in LinkedIn. Visit our GitHub page and add a star to a project. Learn more by visiting our website at vertica.com/python. You can also subscribe to our YouTube channel. See you soon for another video.